And welcome back. Now today we're going to be looking at this little PCB, the external Watchdog timer PCB, made for me by my friends over at JLCPCB. And they did a great job, and I'll tell you for why as we go through the video, because I was quite worried about this. The PCB design is fairly easy, I suppose, and it's straightforward. There's not a lot of components on there. Most of them are surface mount. That diode is not, that transistor is not, and that capacitor could be but isn't. That's where we are really. So yeah, now let's recap what is an external Watchdog timer. Well, it uses a 555 or a 7555 timer IC that if it does not receive a pulse every few seconds, it will reboot your Arduino. In fact, it will cut the power to your Arduino, or whatever part of the circuit is you connect this to, of course. Okay, so if you're not so worried about the Arduino, but you're worried about something further downstream that hasn't replied, it will kill the power to that. Let me show you the circuit diagram after this quick message from JLCPCB. JLCPCB offers custom PCBs with fast, reliable delivery. But today I want to talk about their SMT and PCB assembly from just $2. Let's have a look what that consists of, shall we? So as you can see here, the PCB and SMT assembly is available from $2. How do they do that? So normally there's a $7 setup fee, but in this case they're going to give you a voucher so you don't have to spend that money. Great, all you do is pay for your components. Simple. PCB SMT assembly from $2 from JLC PCB. Why don't you try them out now? Okay, let's have a look at that circuit diagram and just refresh our memories about what this is. Okay, there it is in all its glory. Now, we had a little discussion when I first talked about this circuit about these diodes and resistors and whatnot, and yes, it all came right in the end. Now, I've pre-recorded a bit of video. As soon as I made this PCB and soldered it all up and got it working, I thought, well, I've got to try it out now. So I put a signal generator on it, I put it on the scope to show whether or not pulses at this end here coming in could come in at thousands of times a second to reset this capacitor and therefore ensure that the 555 timer did not cut the power. And why thousands of times a second? Well, imagine you have got this in an Arduino loop, and at the end of every loop you're going send out a pulse on pin XYZ, which comes in at here. We want to make sure that the thousands of pulses arriving at this end are going to turn this transistor, this MOSFET, on and therefore clear down the storage, the charge on this capacitor. Okay, we'll have a look at that bit of code in just a second. The other thing is, these diodes has definitely got to be this way around, not the way that I originally showed you in that circuit that I took this from. I've got two here simply so that I can either put a surface mount or a through-hole component on the PCB. I don't really know of any other way to do it. If you're going to have either or, I suppose I could have just put holes on or something. But anyway, I put two diodes on here. As it happened, the surface mount diode was so tiny, really tiny. It must have been a 0402 footprint that I stupidly chose. Not that I was ever going to go down the surface mount route for the diode, because I've got so many of these 1N4148s through hole components. I literally have probably 50 up there in my little storage thing, so I thought that's what I'm going to use anyway. So no harm done. The other thing is the power that this takes when it's on, because I've got an LED here and it's only through this 180 ohm resistor. It does take, I'm just glancing at my PSU, it does take 14 milliamps when it's on. Now, if you're running this on battery power, you probably want to exclude these two components, don't you? Or at least, have them optional. That's just a heads up. When this is not part of the circuit, I can't even measure the tiny current that this takes while it's in a flipped off mode. I can't, it's stupidly low. Okay, so for battery power it's great, but that LED's got to be taken out. Right, the PCB then, which we'll have a look in real life in just a sec, but that's what it looks like on the board. As I said, it's fairly straightforward, this one. There's nothing funny about it. There's not even that many components, let's face it. A last minute change I made, if you can see, I had this input signals here, and it sort of followed a natural route through here, through the MOSFET to kill the charge on here, which then made sure that the IC over here didn't switch the power, and the output here, voltage out, is all at this stage. The voltage in here, so you put your 5 volts in here and you get your 5 volts back out again, but controlled by this, or at least controlled by the timing mechanism that's going on. And I thought, you know what, if I've got 1, 2, 3 pins here, why don't I just route this signal in over here so we can have, you know, a sort of umbilical cable going to it, 4 cables instead of 3 one end and 2 the other. It looks a bit messy, doesn't it? So that signal in is identical to that one over there. As you can see, there it is, there's the route. I've just routed it round. I thought that might make more sense, really, give, you know. Well, anyway, that's what I did. Let's have a look. What else did I do on here? I don't think there's anything particularly. Oh, there's the diode. See that surface mount diode? Look, that little tiny space between the 2 squares that I'm highlighting. That's how big it is. And I should have, I suppose, watched that. What package is that? Let's have a look. Oh, that's me. Hang on. Right, there it is. So the package, which you might be able to read just about over here. Where are we? It's this one here. SOD5 length 1.2. Okay, yeah, I should have looked. I just grabbed a 1N4148 and stuffed it in there. Yeah, it's tiny. You probably won't be able to use that as a surface mount device unless you happen to have a particularly good eyesight and yeah, those particular components. So the surface mount one fits perfectly, and as I say, that's why I did it, because I've got thousands. Ditto the 2N7000 MOSFET, of which I have many, both surface mount and through hole, but I thought, well, I'll just use a through hole here to sort of get rid of them. So that's why I did that one as well. Could have been a surface mount though. Right, what about the rear view? Let's just do a quick 3D view on here. I hope it will pick it up. Let's have a look. Oh, it does, good. Oh yes, look, Easy EDA, which is what I'm using here, now has these 3D model components all coming out. Doesn't that look great? I mean, that is really something. It really can bring your PCB to life, can't it? So yeah, I really like that. Good on you, Easy EDA. They keep improving it. Every time I load the thing up, it goes, oh, we got a new version. Obviously, there are fixes as well as enhancements, but yeah, it's good. Right, let's have a look on the back. Oh no, there's nothing special on the back at all. Right, okay. But that's the other thing, of course, I've noticed about PCB design. I'm sure everybody goes through this. You're designing it on screen. If we go back to the non 3D there, so you're working on it like this. You think, that's all right. Yeah, I can do this. That. And then you go, right, give me the full size now. So you go to photo viewer or something like that. If only I could find it. It's up here. And you go, yeah, that's great. And you go, oh, that's not real size. So real size, it's like that. And you go, oh my goodness, that is small. Am I going to be able to solder all these things in? But don't worry. If you've chosen the right components, as I have done for all these, I've chosen 0805 surface mount components on the basis that, well, both an 0805 and an 0603 component will fit on the same pads. So whereas the pads would be smaller if I'd chosen 0603, you couldn't then put an 0805 on there. And an 0805 is quite a bit easier to solder on, actually. Now, I'm pretty sure in my PCB, I've used 0603, so let's have a look. So on this one, yeah, I think all these little tiny things, I think they're all 0603s, actually. So they're not that difficult to solder on, to be quite honest. Yeah. Okay, we'll talk about the PCB again in just a second, but now the principle of this working, of course, this is the signal line. Now this has got to be brought high in order to prevent that switching off. That green LED is the voltage out. So if I touch it on there, see it's on. As long as I keep touching it on there, well, you've got about 5 seconds actually between pulses. So if I move my head out of the way, you'll see that. There we are. But what happens, as I say, if you put, 1,000 or 10,000 pulses down there? Is it still going to work? Okay, watch this bit of video. Right, for the test we're going to be using this QMan arbitrary waveform generator. All we're going to do is generate a square wave of varying mark space ratio, duty cycle, and we're going to make sure that this device stays on. So basically, whilst that green LED there is on, it means power is being supplied through the circuit and keeping your Arduino alive and things like that. Let me get the oscilloscope trace up. So what you're looking at here, the top trace here, that's the square wave being generated by the waveform generator, and the blue line underneath, that's the signal after the capacitor in that circuit. So it's the pulse really that's received and keeping that module alive. So currently we're on 10 Hertz, which is basically about as quick as you can do it manually, stabbing a button. So I'm going to increase the frequency as though it were now part of an Arduino loop cycle, you know, and you might get up to 1,000, 10,000 times a second, depending on what your loop is doing, of course, and maybe your loop is busy some instances and not busy at all others, so therefore you'll generate a pulse much more quickly. So what I'm going to do is increment the frequency of this waveform. So currently it's at 10 Hertz, so let's whack it up a decent bit. I'm going to have to adjust the time base now so we can see what's going on. There we are, that's quite a few more there, and I'll whack it up again. So that's currently now at 1 kilohertz. That's 2, 8, 9, right, that's 10 kilohertz now. And remember, we're watching this light down here to make sure this doesn't power cycle off, which it hasn't yet. Just to prove it will do though, I'm going to kill that trace now on the oscilloscope, so no pulses are being received at all, and within 5 seconds I'd hope that green light would go off. So ready, off it goes, and will the green light go off? There we are, off it goes. So now bink, the power's been recycled, and it will keep doing that now until it gets a pulse back in. So let's turn it back on. Right, there it is, and we'll dial it back down again. Now, I think it's 10 Hertz again, is it? Well, let's make it a little bit quicker. There we are. Right, now if we were to increase the duty cycle on, you know, the on-off mark space ratio to DC mode, that's the equivalent of the Arduino, whatever it is that's giving this the pulse, being stuck in a high mode, right? So the pin's gone high and suddenly that's when the circuit's latched. So let's try and emulate that, because at the moment we've only got a 10% duty cycle. So we'll increase that, and as you can see on the oscilloscope here, we're getting more and more of that duty cycle. Eventually it's going to give up trying to keep up, I think, but now that's still pulsing and therefore this is still staying on. But as soon as I get to 100%, it's like the DC being stuck on, like now. Well, actually, yeah, and hopefully there, and it's gone off, and it will keep recycling now because basically the pin on here has gone high, and the capacitor, of course, is ensuring that we don't get a continual high through here. It's had that one pulse, and that's the end of it. So let me dial that back down. There we are. So that's 93% mark space ratio or duty cycle, and we're back on and we're staying on. So that was just really to prove that no matter how fast or how fat you make that input pulse onto this board, this will stay on. It's very forgiving in that sense, and it does give you 5 seconds in which to give a pulse or thereabouts, and 5 seconds of course is a long time for things to happen in the Arduino world. Cool. Okay, now so we've gone from that breadboard design, look how messy it is compared to a nice little PCB. It's really quite amazing, isn't it, what you can do. Now when I ordered this, JLC also gave me this roll of tape, and I think, what sort of tape is this? It's sort of quite flexible, quite sticky as well. Is this just standard electrical tape or what? Is it some sort of special? It's not Kapton tape, Kapton. I don't know what it is really. I'm not going to ask them. I'll look a total idiot if I don't know what it is they're sending me. So yeah, anyway, that came with it. Now let's talk about the PCBs. Yes, right. Let's move that one out of the way. So as you can see, that is a full panel. Now I've tried panelisation before, and I wasn't that successful. So this time I thought, right, I'm going to let my little EasyEDA design thing do it for me. So let's have a look what that looks like on screen. So this is the PCB design that you just saw a few moments ago. If I zoom back out, there you are, you'll see the writing on there. It says, because I've said panelise this board please, and it goes, okay, do you want bits at the top here, and this strip at the top with these little holes, what I'm pointing to, that one there and that one there, they're for the pick and place machines. Were you to get either JLCPCB to assemble this, which would be quite easy for them to do, or if you've got your own pick and place machine. Yeah, some people do have their own pick and place machines. But as I said, I had trouble previously trying to get a panelised board. So this time I said yes to everything. I said, yes, I'll have a strip across the top. I'll have this mini strip down the middle. See this little gap between one board and another here. And what else did I say? Down the bottom, down here, I'll have another strip down there with the holes and these fiducial line-up holes and whatnot. I said yes to everything. And the way that you panelise this board is simply in EasyEDA, you do this. Right, I've just realigned the screen so you can see the top bit, which takes up real estate normally. But on the toolkit thing up here, click Panelise. You can remove it by clicking that, which is what I've just done, so that's a nice clean thing. I don't want any holes. Yes, I do want a V-cut. That means you can just snap the board out. Columns, rows, I can't remember what I said now. Well, it probably was all these things here. Yes, I'll have a border. Yes, I'll have positioning holes. Yes, I'll have fiducial marks. Basically, I just left everything pretty much as it was and said apply. And that's it. It's done it. Look at that. Amazing. And it says only panelise the board outline. So we're not getting all this circuitry on each one of these, which is what I tried to do before. All PCB factories support this panelised file. And I'm thinking, well, if EasyEDA is telling me that, and they're linked to the JLCPCB group, I'm guessing JLCPCB will know exactly what to do with this board. But I did have my doubts, and to be absolutely honest with you, if this had come back not with 6 PCBs like this on it, but 1, and then 5 other blanks, I would not have been surprised. But as it happened, it just worked. I think this is amazing. So what they do their end, I'm not quite sure. They obviously look at this Gerber file that we generate and go, okay, you want this panelised, and we just replicate that one in all these other ones. They just did it. I don't know. It was a worrying moment, but there we are. So obviously I ordered 5 of these boards, thinking, okay, well, at least I'm going to get 5 of these, because I probably want, well, I'm going to use these in my project, certainly. At least first thing that's going to be done is my fridge alarm that keeps hanging up every few weeks. But I think, okay, I'll need 5, but what happens if I get them all? Okay, well, I'll have to give a few away. So what I'm going to say is, if you want one of these little tiny boards, and I've had a couple of requests already, I'm still waiting for responses from people. By the way, you know who you are, so I've asked you for either addresses or whether you want it sent to a certain place or not. I'm going to limit this first of all to UK people, because we had that postage issue, didn't we, last time? It just, the work and the effort and the fiddling about. Long story short, basically, postage in the UK I don't mind paying for as part of the feedback to my viewers. But when it goes to the States and Australia and Europe, and it's £2, 60, 70, 80 a time, that just really adds up and wipes out anything that I earn on this video. So I said no. So what we did then was a PayPal postage thing, and that just got totally out of hand, because PayPal kept telling me, oh, somebody's paid for this and somebody's paid for that, and I have to go in and dig out the address and print. It was just horrendous. I don't know how these people, these eBayers or other people that use PayPal, have a slick operation to do all that. I really don't, but I'm not set up for it. So what I'm going to say is, if you have a UK address, UK, and you want one of these little tiny panels, not this whole thing, just one of these, all right, email me, and you know where my email address is in the About tab of this channel, and say, please, Ro, can I have one of those? I go, yes, as long as you've given me an address. As I say, I'm waiting for a couple of responses back who have requested already. I know, some people just jump the gun, don't they? Right, and if there's any more left, read the comment. I'll put a pinned comment under this video, right, to say there are still some available, or I might open it out to the rest of the world, but then we'll have to think very carefully about the postage. It's just so awkward, isn't it? So awkward. I wish I could give one away to everybody. I really do, because this is a nice little board. Though I say it myself, but then of course the design was not mine, was it? You have to look at the other video. What other video? That video there where we talked about it. Come on, you really haven't been paying attention, have you? Come on now, keep up with the game. Right, okay. I think we're sort of done here, really. Probably quite a quick video. It feels quick. But then, of course, I've got that bit to drop in. Post-editing magic and all that. Yes, I know. Right, now, if you like this video and you think, yeah, I can either make my own external Watchdog timer thing or grab one from Ralph or whatever, please go ahead and do it. JLCPCB make these wonderful panelised boards. I'll be using this system of panelisation again when I have a small board, because you're allowed a PCB up to 100 by 100 millimeters, and that is not 100 by 100, I might add, so I can fit 6 in there. I hope they don't mind me saying this, because it means you're going to get more PCB, doesn't it? You know, raw PCB, but that's the rules of the game, so I guess they don't mind at all. Okay, that's it. Yeah, comments down below, please. Anything you want to mention about this, one way or the other. If you like this video, please do give it a like, because YouTube like knowing that. The more likes you give it, well, you can only give it 1 each, obviously. The more they think, oh, people like that video, I'll go and recommend it to other people. And it's quite disheartening when you do a video and YouTube come back and goes, oh, your viewers showed less interest than normal in this topic. You go, no, why? Why? Luckily, it does pick up over time, usually, but not always, not always. So do, please give it a like and comments, and that's it. I'm going to see you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.